Okay, this video is supposed to accompany the 2-4 additional practice. So let's see what we got here. Slopes of parallel and perpendicular lines. So handrails installed along the stairs of a new house is shown in the figure. Table shows the distance of the top rail and bottom rail from the floor. So this f of x are the y's that go with the rail. The g of x are the y's that go with the bottom part of the railing, and the x's are going to be the same for both of them. Determine the slope of each rail. Are the bottom and top rails parallel? So what we need to do is, this is really like two separate data sets. So we got like 1, 9, 216, and 323. This is the F ones. And then for the G ones, we have 1 with a 43, we have 2 with a 50, and we have 3 with a 57. So what I want to do is, or what we want to do, is figure out the slopes. And I'll use the two endpoints. So I want to figure out the slope using 1, 9, and 323. So change in y over change in x. 23 take away 9 over 3 take away 1. This is going to be 14 over 2, which is 7. So the slope of this top rail is equal to 7. Now, if the bottom rail is parallel, it's going to also have a slope of 7. Let me change colors. So I'm going to do the same thing here. I'm going to use 357 and 143. So I'm going to do 57 take away 43 for the change in y. And since I use 57 first, I have to use its matching x first in the bottom. 3 take away 1. So this also gives me 14 over 2, which is also a slope of 7. So the slope of the bottom railing is also going to be 7. So yes, they are parallel. Both have slopes equal to 7. Okay, let's look at number 2 here. So determine whether each pair of lines are parallel or perpendicular, right, yes or no. So Q and V. The trick with these on the graph, on the grid, is to find a couple of points where the line goes through the grid on the graph. So here's Q, here's a point, Q where it goes through the intersection, and here's another point I can use. So that's 2 points I can use for Q's slope. That's negative 1, 2, 3, negative 4, 1, 2, 3, 4, 5, 6. So we're using negative 4, 6. This is for Q. And we're also going to use over 1 up 1, 2, 3, 1, 3. So we're going to use those 2 points to find the slope for Q. And we need to also find the slope of V. Change colors. So V is this line here. Looks like, where's the place it goes? Here, it goes through right there. And right there. So there's 2 places I can see where it goes through the grid. So one of them is negative 1, 2, 3, 4, 5, 6, 2. Negative 6, 2 actually. And the other point is 1, 2, 3, 4, 1, 2, 4, negative 4. So we got to figure out what the slopes are. If the slopes are the same, they're parallel. If the slopes aren't the same, they're not. So 6 take away 3. So I'm back to the red one now. I'm doing Q. 6 take away 3 over negative 4 take away 1. 6 take away 3 is 3. Negative 4 take away 1 is a negative 5. So we get a negative 3/5 for the slope on Q. And we want to do the same thing for V. So I'm going to do 2 take away negative 4 over negative 6 take away 4. Okay, so 2 take away negative 4 is the same thing as 2 plus 4. That's the same thing as a 6. And 6 take away 4 is a negative 10. So this simplifies to negative 3 over 5. So negative 3 over 5 and 3 over negative 5, exactly the same thing. Yes, these are parallel. Okay, I'll just do the evens on these, and I'll leave the odds for you guys to complete. Let's look at number 4, R and T. So here's T, and here's R. So it's obvious that T and R are not parallel to each other, and they're not perpendicular to each other. So that's going to be a no. We don't even have to worry about that one. Let's look at number 6, Q and S perpendicular. Here's Q. Here's S. Q and S obviously don't make a right angle when they cross. That's also going to be a no. Let's look at number 8, R and S perpendicular. Here's S. Here's R. Now they look like they're perpendicular. Let's see. So what I need to do is I need to find a couple of points on R where I can calculate the slope. So I'm going to use that point there and this point here. So this is going to be negative 1, negative 2, 1, 2, 3, negative 2, 4. We're talking about R now, right? R. And another point was 0, negative 1, 2, 3, 4, 0, negative 4. Now I also need to pick 2 points on S. So here's S. There's a point on S I can read. Here's a point on S that I can read. So one of the points is over 5, up 1, 2, 3, 4, 5. So 5, 5 is one of the points. Another point is back 3, up 3 is 3, negative 3, 3 is another point. So I want to calculate the slopes between these. If I do negative 4, take away 4 for the change in y's, over 0, take away negative 2. This gives me negative 8 in the top, and take away negative 2 is a plus 2. So we got negative 8 over 2, which gives us a negative 4. So now if this one turns out to be a negative 1 or positive 1/4, they're going to be perpendicular because that would be the negative reciprocal. So if I take negative 4, put it over 1, flip it upside down, and make it the opposite, I get 1/4. So negative 4 and 1/4 are going to give these slopes of perpendicular lines. So I would need to check this one and see what we get. So I would do 3 take away 5 over negative 3 take away 5. 3 take away 5 is a negative 2. Negative 3 take away 5 is a negative 8. This simplifies to positive 1/4. So we've got a positive 1/4 slope with a negative 4 slope. If I was to multiply these together, negative 4 times 1/4, gotta put that over 1, we get negative 4 over 4, which simplifies to negative 1. So these are negative reciprocals. They give us, the reciprocal gives us the one part, the negative gives us the negative part. So these are going to be perpendicular. That's going to be a yes for that one. Okay, let's look at number 10. Write equations for the line. So you still need to do the odds also and show your work. Let's do number 10. Now number 10, they're giving us a reference line. So all this reference line here does is give us the slope that they want us to use. That's all this line is good for. They're giving us the slope. They're serving us up the slope. So they're saying, write the equation of a parallel line, that's going to be a line with the slope of 2, that goes through the point 0, 1. And also, they want a perpendicular. So if I think about 2 times what makes a negative 1, divide both sides by 2, x is a negative 1/2. So negative 1/2 is the perpendicular. So the perpendicular slope is going to be negative 1/2. The parallel slope is going to be 2. And that's all this line does, is serve up the slope for me to use. And so this line is also going to go through the point 0, 1. So I have a point and a slope. Also, I really have a slope and an intercept. So I can actually use slope-intercept on this one. This is going to be y equals 2x plus 1. The slope is a 2. And the y-intercept is a 1. This perpendicular one is going to be y equals negative 1/2 x plus 1. And so this one's going to be the perpendicular one. This is going to be the parallel one. Parallel one has the same slope as the reference line. Perpendicular one has a negative reciprocal slope. We made it go through the y-intercept. Now, more typically, you're going to get one like number 12, where they're not going to give you the intercept, or you're maybe not recognize it's the intercept. So the reference line says that the slope needs to be a negative 5. That's all this line's good for. So m is a negative 5 for the parallel, and m of the perpendicular. So if I do negative 5 times x equals a negative 1 and solve for x, I get a negative 1 over negative 5, which is 1/5. So 1/5 is the perpendicular slope. So I want to write a line equation that has a slope of negative 5 that goes through negative 4, 2. That's point slope. So point slope form, remember, is put up here, y minus y1 equals m, x minus x1. So y minus 2 equals m, which is 5, times x minus a minus 4 turns into plus 4. So here's the parallel line equation. And I want to do the same thing for the perpendicular line. So I need to use the other slope, which is, this was a negative 5, not a positive 5, negative 5. The other one is a 1/5. It's going to be the same thing. Y minus 2 equals 1/5. There's the perpendicular slope. X minus negative 4, which is plus 4. So here we have the equation of the perpendicular. So all the reference line does is serve up the slope that I need to use, which is a negative 5 for parallel. From that, I can figure out the negative reciprocal of that, or the number that would make it equal a negative 1, is 1/5. Perpendicular line is going to have a slope of 1/5. Parallel line is going to have a slope of negative 5. They're giving us a point it needs to go through. So I put the y in for the y1 part. I put the minus 4 in for the x1 part. Minus and minus 4 is plus. And same thing on the other side. So the only difference of these is they're both going to go through the same point. One's going to be perpendicular to the other because one's going to have a slope of 1/5. The other one's going to have a slope of negative 5.